Uh, a very good morning to all, or we say a very good afternoon, right? So today, this is the second class of this chapter, that is more concept and equivalent concept. In the first class, we are discussing about the some various concept behind this. What is mole concept? How we solve numerical related to sociometric, and we also see different types of numerical on this, right? So in today class, we are going to see some titration parts which is basically for the advanced topic only. And after this, we are going to solve more numerical. So today we are going to focus more on numerical, right? So please try to understand this thing. Okay. So that we can, try to solve much more as question as we can, right? So let's start with the today's session. I hope my voice and my screen is visible to you. My screen is visible to you all. Yeah. And my voice is also audible, right? Okay, so let's start now. So this question, I was given in their homework question. This question as, so what the question asked basically. I hope many of you try this question and also solve out this question as well, right? So what is the question basically? So this question is. This is J advanced question. This is a PYQ question coming, I guess 2019-20 question. So what the question asked basically from you? The question is, the ammonia prepared by titrating ammonium sulfate and calcium hydroxide is completely used by NiCl4.6H2O to form a stable coordination compound. Now, assume that both the reactions are 100% complete, right? Both the reactions are 100% complete. Now, if 1584 gram of ammonium sulfate and 952 gram of NiCl2.6H2O are used in the preparation, the combined weight in gram of the gypsum and the nickel ammonium coordination compound is. Yes, so you have to calculate the combined weight in a gram of the gypsum and the nickel ammonia coordination compound, right? So let's see how will you write this thing and how we can actually solve this thing, how to write the equation for this question, right? Because the main important thing here, how to write the equation, then you can able to solve questions only, right? So for this question, for this particular question, you need to write the equation first, then only you are able to solve the question. So let me show in the first statement what it say beta. It say that write the reaction when when ammonium sulfate, right? When the ammonium sulfate is treated with calcium hydroxide. So what happened when the ammonium sulfate? What is the formula of ammonium sulfate, beta? So let's see this. What is the formula of ammonium sulfate? We know that. Let me just wait for a minute. Right. So we know that this is ammonium sulfate. That is nothing but NH4 twice, and this is SO4, right? So this is ammonium sulfate, and this react with calcium hydroxide, that is CaOH2, right? So this ammonium sulfate react with calcium hydroxide, okay? And when the ammonium sulfate react with calcium hydroxide, it will produce CaSO4.2H2O, also known as gypsum, right? So this is also known as gypsum, gypsum, and 2NH3, right? And 2NH3. Okay, so this is the reaction. Now in the second statement, it state that uh, completely used by NiCl2. यानी जो अमोनिया यहाँ बना है, the amount of ammonia formed here is directly used by NiCl2 6H2O to form a stable coordination compound. So what happened in the next step, beta? That is NiCl2 dot 6H2O use this ammonia, that is NH3, to form a stable coordination compound. What stable coordination compound? Like NiCl2 and this is nothing but NH3, right? NH3, 6, and this is Cl2, right? This is Cl2 plus 6H2O. So this is 6H2O. So this is NH4 2SO4 plus CaOH2. This react to give CaSO4.2H2O, that is called gypsum, plus 2NH3. Now NiCl2.6H2O plus NH3. This will give NiNH36Cl2 plus 6H2O. Now the question is clear to you. Now we can see the equation. What the equation for this reaction? Now in this question they say you have to calculate when the both the reaction are 100% completed, and if 1584 gram of ammonium sulfate. So here amount is given. What is 1584 gram of ammonium sulfate is, and 952 gram of NaCl. So this is also given, 952 gram of NaCl to 6H2O. Now, you can tell me one thing, beta. When the 1 mole of ammonium sulfate react with 1 mole of calcium hydroxide to produce 1 mole of gypsum plus 2 mole of ammonia, right? Now, in 1584 gram, how many mole of ammonium sulfates are present? How many mole of ammonium sulfate are present, beta? Can you calculate, anyone? Yes, we can calculate. How we can calculate, beta? We can calculate as, because we know that this thing, mole is what? Mole is nothing but mass upon molecular mass. So here mass is given, that is 1584. Just divided by the molecular mass, you get the number of mole. So what is the molecular mass of ammonium sulfate, beta? So molecular mass of ammonium sulfate is nothing, but it is equal to N. For N, we know that it is 14 already given. And H4. So H4 means that is 4, and this is twice, right? So this will be 2 times, that is 2 into 14, and this is 4 into 2. Now sulfur is what? Sulfur is 32 and oxygen is again 4 into 16, right? So on solving it comes out to be 28 plus 8, right? 28 plus 8 plus 32 plus 64. So just add them, just add all of them. So what you will get, beta? When you add this thing, that is 28 plus 8 plus 32 plus 64, you'll get 132, right? So just divide this 132. So 1584 divided by 132, it comes out to be 12, right? It comes out to be 12. So 12 mole, right? We can know this thing, how we'll convert mass into mole and mole into mass. We know this thing from the first class as well, right? So the 12 mole of ammonium sulfate produce 1 mole of gypsum, right? 1 mole of gypsum and 2 mole of ammonia, right? 2 mole of ammonia. Now we know that this is equal to what? This is nothing but this is equal to, this is equal to which value, beta? Can anyone tell? 1 mole of this is equal to what? 1 mole of this, if I say 1 mole of this produce 1 mole of gypsum, then 12 mole of ammonium sulfate also produce 12 mole of gypsum, and 1 mole of ammonium sulfate produce 2 mole of ammonia. So 12 mole of ammonium sulfate produce 24 mole of ammonia, right? So here it produced 12 mole. I can write 12 mole, and this will produce 24 mole of ammonia. Mole of ammonia. I hope this is clear to you, right? If 1 mole of ammonium sulfate produce 1 mole of calcium sulfate, or we say gypsum, then obvious na 12 mole produce 12 mole, and 1 mole produce 2 mole of ammonia. It means 12 mole produce 24 mole of ammonia. So this is very much clear, right? On the similar basis, this is 952, and when you divide it with their molecular masses, it comes out to be 4 mole. It is equal to 4 mole. On similar basis, beta, just like that, just calculate the molecular mass of NaCl2.6H2O and divided with 952 gram, you'll get 4 mole, right? So 4 mole of this produce, how many mole? 4 mole required. So if 1 mole required, if 1 mole required 6 NH3, so 4 mole required, beta, 24 mole of NH3, right? 24 mole of NH3, and this is also given, that is it is 1 mole, so it is equal to 4 mole, right? So now you have to calculate the combined weight of gypsum and nickel ammonia. So what is the combined weight, beta? So the combined weight of gypsum and nickel ammonia coordination compound. So here gypsum is what, beta? So gypsum is nothing but 12 mole. So we know that weight mass is equal to what? Mole into molecular mass. So molecular mass of gypsum comes out to be 172. We can easily calculate now. We know that calcium is 40 plus sulfur is what? Sulfur is S है. S is here, na? Sulfur is 32 plus oxygen is 4 into 16. That is 64, right? So this is 64. So this is 64 plus 2 into 18. So we can calculate here. It comes out to be 172. So 12 mole into their molecular mass. So 172 plus what is the mass of the nickel ammonia coordination compound? Nickel ammonia coordination compound means 4 into their molecular mass, that is equal to 232, right? That is 232. So on solving, what we get, beta, that is 2992 gram. So this is the correct answer. That is what the correct answer is, beta. The correct answer here is 2992 gram, yani 2992 gram is the correct answer for this question. I hope this is clear to you. Anyone having any kind of doubt? Yeah, you can ask me, beta. सबको क्लियर है ये? Right? Good. So this is all about how will you actually find the weight of this, right? So this is the way to find the weight. So this question is very important, and this is a PYQ question of JEE Advanced only, right? So this kind of question also asked from this chapter, that is mole concept and equivalent concept. So for this question, you need to know how the reaction is going on, how to write the balanced chemical equation, and how to use the mass and mole concept. So if you know this thing, then you can able to solve such questions, right? Okay. Now let's move to the next question. Next question, or we say next topic. So this topic we are going to do today. That is, we are going to see some different type of volumetric analysis, or we say titration. So different type of titration we are going to see, and from each titration we are going to solve one numerical, so that our concept become also clear. Now the first one is a simple titration. What do you mean by this term simple titration? What is this simple titration, beta? So basically in simple titration, in this, a solution of substance A of unknown concentration is made to react with the solution of B with the known concentration. What is happening here? It means a solution of substance A. It means we have a two solution, right? And concentration of one solution is known, and the concentration of the another solution is unknown, right? So we have in this we have a two solution, that is a solution of substance A of unknown concentration is made to react with the solution of B with the known concentration. It means two solutions there, and one of them having known concentration, another we can't know the concentration of the solution, right? So the two are reacted in a such a way that the volume of the V required to completely react with A can be found out by using some indicators. Thus the concentration of A may be calculated. So in this method, basically we use to calculate the concentration of the unknown solution, right? So how it takes place, beta? Basically in this, when the two are reacted in a such a way that the volume of the V required to completely react with A can be found out by using some indicators, just like we done this thing in our lab also, when we treat KMNO4 with the Mohr salt and titrate it, right? So these kind of titration in which we find out the concentration of the unknown solution like Mohr salt and KMNO4. So by using some different like Mohr salt, oxalic acids. So these are the called the simple titration, in which the we can titrate it to find the unknown concentration of a solution A with respect to the known concentration of the solution B. Right? So I hope this is clear to you. यस, क्लियर है सबको यहाँ तक, कोई इशू नहीं? Right. Okay. So if the normality of B is N1 and its volume used is V1, then the gram equivalent of B reacted is equal to N1 into V1, right? So let us assume if the normality of the solution B, because we know that for solution B, we know the concentration, right? So if the normality of B is N1 and its volume is V1, then the gram equivalent weight of B is reacted is nothing but is equal to N1 into V1. We know that. Now, according to the law of equivalent, the gram equivalent of A would be equal to that of B. So we can write the gram equivalent of A is equal to N into V. If the volume of A is V, then the normality of A would be N1 V1 upon V. So this is how we can find. This is the normality, that is N, right? So this is the normality of the unknown concentration, that is N1 V1 upon V. So let's see some numerical related to this and then try to understand this thing as well, right? Okay. Now, so for such question, let's see, we have a one question for this. How can we solve this question? Because this question is directly related to this. So in this question, what the question asks, beta, in this question, the already given, the ammonia, that is NH3 release on the quantitative reaction of 0.6 gram of urea, right? 0.6 gram of urea with the sodium hydroxide. So in this, we having a titration with the urea with the sodium hydroxide can be neutralized by, right? So the ammonia release on the quantitative reaction of 0.6 gram of urea. So here the concentration of urea is given, or we say the amount, that is 0.6 gram of urea is given. Now we do this titration with the sodium hydroxide. So we have to find out the volume and the normality of the unknown solvent, like here sodium hydroxide is there. Okay, so we have to find the concentration of this unknown solvent. So how will you approach, beta? Let us first of all write the reaction. So what happened when the NH2 CO NH2, right? When the NH2 CO NH2 react with 2 NaOH, right? When they react with 2 NaOH, so it will produce 2 NH3, right? So it will produce 2 NH3 plus Na2CO3, right? So when the NH2CO NH2 react with the 2 NaOH, it will produce 2 NH3 plus Na2CO3, right? It will produce Na2 and CO3. We know that the molecular mass of ammonia is what? Molecular mass of ammonia is nothing but 60. How it come, beta? And we know for nitrogen we have a 14, hydrogen 2, carbon 12, oxygen 16, again nitrogen 14 plus hydrogen 2. So on adding, we'll get this is equal to 16, right? So molecular mass of urea is nothing but 60, right? Now, number of moles of urea is equal to given mass upon molar mass. So if you know the molar mass, if you know the given mass, then we can also calculate the moles of urea now. So what is the moles of urea here? So moles of urea here is nothing but given mass, that is 0.6 upon the molar mass. So the mole comes out to be 0.01 mole, right? 0.01 mole. So 0.01 mole of urea is present, right? So now it is given that 0.02 mole of NH3 as per the equation. Now if we consider this equation, it is already given that the amount of NH3 released on quantitative reaction of 0.6 gram of NH2OH with the sodium hydroxide can be neutralized by. Okay, so you have to find it can be neutralized by. So how many way, how much volume of the sodium hydroxide of the normality is needed, right? So how it will find that, beta? We already know this thing, right? So it give already 0.2 mole, because we know that 1 mole of urea give 2 mole of NaOH, right? So 0.01 mole give how much? Just multiply by 2. So from the this stoichiometric coefficient, we know that 1 mole of urea, 1 mole of urea give 2 mole of ammonia, 2 mole of NH3. So 0.01 mole will give 0.02 mole of NH3. Is it true? Right. So 0.02 mole of NH3. Now, to neutralize it, 0.02 equivalent of HCl is needed, right? So, to neutralize this, 0.02 mole of equivalent HCl is needed, because here this is base now. So 0.02 mole of uh, NH3, sorry, HCl is needed. So as we know that number of equivalent of HCl is nothing but what? Normality into volume. Okay, so I can write here number of equivalent, right? Number of equivalent of HCl. HCl is nothing but is equal to normality into volume. Normality into volume. Therefore, the normality is what? Normality, what beta? Normality into volume. So what is the normality here? Can anyone tell me? To neutralize it, 0.02 equivalent of HCl is needed, right? So let us assume, consider this first equation. So in this 100 ml, 100 ml of this, so we can convert this into liter, right? So this is 100 ml converted into liter, and what is the normality of the solution? That is 0.2. So on solving, it comes out to be 0.2, right? And how much we required also? 0.2 mole of NH3 produced now. So we also required 0.02 mole of HCl, right? So this is absolutely correct answer. Now, if you consider this one now, it comes out to be 200 into 10 ki power minus 3 into 0.4. So it comes out to be different, right? So this is not the correct. So correct answer is option A. Because to neutralize it, 0.02 equivalent of HCl is needed. So according to equation 1 only, in this only 0.02 equivalent of HCl is present. So the correct answer for this question is A. I hope this is clear to you. Right? Good. Now, the second one is back titration. The first one is simple titration. Now we are going to discuss about the back titration. What is this back titration? What is this all about, back titration and all? So let's see what is back titration and all. So first of all, this is the titration method in which the concentration of one analyte is determined by reacting it with a known amount of excess reagent, right? So this is the titration method in which the concentration of one analyte is determined by the reacting it with known amount of excess reagent. The remaining excess reagent is then titrated with the another second reagent, right? The result of the second titration show that how much of the excess reagent was used in the first titration. Now from the data, the original analyte concentration is calculated. So this is also a very interesting method, also known as a back titration method. In this method, basically what we do now, in this titration method, the concentration of one analyte is determined by reacting with an amount of excess reactant. It means in this one reactant whose analyte is to determine is in lesser quantity and the another is in present in excess quantity. Now the remaining excess reagent is then titrated with another second reagent, right? And the result of the second titration show that how much of the excess reagent was used in the first titration. Now from this data, the original analyte concentration is calculated, right? So this is all about the back titration and all. Okay, so let's see. Okay, so this is the example number 30 we have. So this is nothing but 1.6 gram, right? So this is 1.6 gram of pyrolusite ore was treated with 50 centimeter cubic of one normality oxalic acid and some sulfuric acid. The oxalic acid left undecomposed was raised to 250 cubic centimeter in a flask. 25 centimeter cubic of this solution when titrated with 0.1 normality KMnO4 required. 32 centimeter cubic of the solution, find out the percentage of pure amino 2 in the solution, right? So you have to calculate the pure amino 2 in this reaction. Okay, so let's see how to solve this question. Okay, so first of all, beta, we know that molar equivalent of excess dilute oxalic acid in 25 cc is what? That is molar equivalent of KMnO4, right? Molar equivalent of KMnO4, which is equal to what? Which is equal to what, beta? Can anyone tell? It's already given now. This is 0.1 into 30 T Cn. The volume is already given. That is nothing but 0.1 and this is 32. So this is the molar equivalent of excess dilute oxalic acid in 25 centimeter cube is equal to molar equivalent of KMnO4, right? Molar equivalent of KMnO4. So this is equal to molar equivalent KMnO4 is what? 0.1 normality into 32. So it comes out to be this. That is 0.1 into 32, or we say 32 upon 10, or we say 3.2. Okay, so this is equal to 3.2. Now, on the similar basis, molar equivalent of oxalic acid, right? Molar equivalent of oxalic acid. So you have to calculate the molar equivalent of oxalic acid in 250 centimeter cube dilute solution, right? So molar equivalent of oxalic acid in 250 cc dilute solution is equal to nothing but 32, right? Is equal to 32. I hope this is clear to you. This is equal to 32. Now, let's see the next page. Now, molar equivalent of MnO2 is equal to molar equivalent of oxalic acid minus molar equivalent of what? Of excess of oxalic acid. How much oxalic acid is excess, right? Of oxalic acid. So it's equal to how much, beta? That is molar equivalent of oxalic acid is nothing, but it is equal to 1 into 50 minus 32, which is equal to 50 minus 32. It's equal to 18, right? So this is the molar equivalent weight of MnO2, which is equal to 18. Now, let the weight of let us assume the weight. So let the weight of MnO2. Let the weight of MnO2 is W gram, right? So let the weight of the MnO2 is W gram. So what is this equal to? W upon E into 1000 is equal to 18 gram, right? So from here we can calculate this is W, and what is this equivalent weight? It is nothing but 87 upon valency factor. So it is equal to 1000 is equal to 18. So from this you can calculate weight. So what the weight comes out to be? Can anyone tell? Weight is nothing but 87 divided by 2000. So it is equal to 0.783 gram, right? So in this question, what they ask? Percentage. So percentage of MnO2 is equal to 0.783 gram divided by 1.6 into 100, right? Divided by into 100. So it comes out to be 48.93. So this is the absolutely correct answer, right? So let's see the solution again. In this question, they are saying 1.6 gram of pyrolusite ore was treated with the 50 centimeter cube of 1 normality oxalic acid and some sulfuric acid also. The oxalic acid left undecomposed was raised to 250 centimeter cube in a flask. Now, the 25 centimeter cup of this solution when titrated with 0.1 molar of KMnO4 require 32 cc of the solution. Find out the percentage of pure MnO2 in the sample. So you have to find the percentage. So first of all, we have calculated what we calculated here. That is a molar equivalent of excess dilute oxalic acid in 25 cc, right? And it comes out to be molar equivalent of KMnO4, which is equal to what? 0.1 into mid 32, because we know that molar equivalent of KMnO4 is what? That is normality and multiply by its volume. So it's 0.1 into mid 32. On the similar basis, molar equivalent of oxalic acid in 250 centimeter cube solution is also equal to 32, because this is already given now in 250 having one normality solution. So this is equal to 32. Now, molar equivalent of MnO2 is equal to molar equivalent of oxalic acid minus molar equivalent of excess of oxalic acid. So this is equal to 1 into 50 minus 32, which is equal to 18. Now let the weight of the MnO2 is W grams. So W upon E into 1000 is equal to 18. So on solving, we get W is equal to this much, right? Now percentage of MnO2 is nothing but it comes out to be 48.93. So 48.93 is the correct answer for this question. I hope this is clear to you. Okay, good. Now, the third type of titration is called double titration. So, what the double titration means, beta? So, this titration of the specific compound using a different indicators, right? So, in this is a titration of the specific compound only for selected compounds using a different indicators. This method involves two indicators, namely phenolphthalein and the methyl orange. These two indicators, that is phenolphthalein and methyl orange, used as a indicator. These indicators are weak organic acids or base which show completion of reaction by change its color. So how will determine the reaction is completed or not? So the indicator are weak organic acid or base which show completion of reaction by changing its color. Now, phenolphthalein act as an indicator in weakly basic medium. Remember this word. Remember this thing. That is phenolphthalein act as an indicator in weakly basic medium, but not in acidic medium. On the other hand, methyl orange act as an indicator both in acidic medium as well as basic medium. So this point you must remember, that is double titration. So first of all, this titration is a specific compound using a different indicators, right? So this is the titration of the specific compound using different indicators. The second one is this method involves two indicators, namely phenolphthalein and methyl orange. These indicators are weak organic acids or base which show completion of reaction by changing its color. Next, phenolphthalein acts as an indicator in the weakly basic medium, but not in the acidic medium. On the other hand, methyl orange acts as an indicator both in acidic medium as well as in basic medium. So I hope this is clear to you. Okay. Now, the extent of different bases with the SCl using these two indicators is summarized below, right? So how will you summarize this thing? Indicator used with the different bases. The first one is bases, phenolphthalein and methyl orange, right? So this is the basis, this is the phenolphthalein, methyl orange. So what bases we use? That is NaOH, Na2CO3, NaHCO3. So these type of bases we use. Now phenolphthalein, 100% reaction is indicated. Na2CO3, 50% of reacting up to NaCO3 stage is indicated. No reaction is indicated, right? Now, in this Na2CO3, now once NaCO3 is formed, then the reaction becomes stopped, right? So in NaCO3, no reaction is indicated. By using methyl orange, 100% reaction is indicated, 100% and 100%. So the methyl orange can give with the any one of this, like acid base both, right? Suppose the volume of the given standard acidic solution HCl is required, then suppose the volume of the given standard acidic solution HCl is required for the complete reaction of NaOH is V alpha, right? So we can represent for the complete reaction of NaOH VAML, for the complete reaction of Na2CO3 VBML, and for the complete reaction of NaCO3 VCML. There may be a different combination of the mixture of the bases are possible also. So we'll opt the following two methods. The first method is we carry two titrations separately with the two method different indicators. Or in second method, we carry single titration, but adding second indicator after the first endpoint is reached. So we use either of these two methods, either method 1 or method 2. So in method 1, we carry the two titration separately with the two different indicators. In method 2, we carry a single titration, but adding second indicators after the first endpoint is reached. So let's see the how the result comes out in this. The result with the two indicators in the two different methods. So this is the method number 1 and this is the method number 2. So let's see the method number 1 first. So in this we use a mixture of NaOH plus Na2CO3. So phenolphthalein give the volume of Va plus Vb by 2. Now when you use the mixture of NaOH and NaHCO3, then it also always equal to only Vb. Now Na2CO3 NaCO3 Vb by 2 only, right? So this is for phenolphthalein when the volume of HCl are used as an indicator, right? So this is for phenolphthalein. Similar for the methyl orange, because methyl orange give 100% reaction. So this is Va plus Vb, Va plus Vc, and Va plus Vc, right? So this will give the whole one. Because we already know na Vc. What is Vc? A volume of the NaSCO3. What is Vb? Volume of the Na2CO3. So on like that, we can write here Va, Vb, and Vc. Okay. Now, on the similar cases for the method number 2, what we use, that is Va plus Vb by 2, Va, and this is Vb by 2. This is again after going this Vb by 2, this is Vc, and this is Vb by 2 plus Va. So if the mixtures contain NaOH, Na2CO3, and NaSCO3, then the following are the cases that occurs. What the cases occurs, beta? That is case 1. That titrate reading of HCl using phenolphthalein from the beginning is equal to V alpha plus Vb by 2, right? V alpha plus Vb by 2. Case 2. If the methyl orange is added after the first endpoint, then the titrate reading of HCl is Vb by 2 plus Vc. Okay, then it is equal to Vb by 2 plus Vc. Now, in case third, if methyl orange is added from the very beginning, the titrate reading of HCl is equal to Va plus Vb plus Vc, right? Va plus Vb plus Vc. So this is how we actually calculate this thing, right? So if the mixtures contain NaOH, Na2CO3, NaSCO3, then the following are the cases we get, right? So we have a three different cases. The first one is the titrate reading of HCl using the phenolphthalein from the beginning, that is Va plus Vb by 2. And the second case, if the methyl orange is added after the first endpoint, then the titrate reading of HCl become Vb by 2 plus Vc. And if the methyl orange is added from the very beginning, the titrate reading of HCl become Va plus Vb plus Vc. So I hope in this there is no problem. Is everything clear to you? Good. Now, this is the example number 31. So what the example 31 basically wants from you? This is a solution contain a mixture of Na2CO3 and NaOH, right? So a solution contain a mixture of Na2CO3 and NaOH. Using phenolphthalein, that is TiPH, as an indicator, 25 ml of mixture required, 19.5 ml of 0.995 normality of HCl, right? Now, what the next thing is? Endpoint with the methyl orange, 25 ml of solution required, 25 ml of the same HCl for the endpoint. The gram per liter of Na2CO3 in this mixture is, so you have to calculate the gram equivalent of this, right? So you can try this question. If you face any problem, then we'll discuss this question in tomorrow class. So this is a homework question for you all, and try to solve this question on your own basis. If you're able to solve this, then it's good. If you're not able to solve, then we'll discuss this question in tomorrow class, right? So let's see the next thing. The fourth one is iodometry. So what is this iodometry, beta? So this is a simple redox titration between a solution of iodine and Na2H2O3 solution. So remember this thing. What is IOD? Iodimetry. So this is a simple redox titration between a solution of iodine and Na2H2O3 solution. In this, I2 is react with 2H2O3 to give 2I negative plus S4O6 twice negative, right? So this is a simple redox titration between this solution of iodine and this. So always remember whenever someone asks what is iodimetry. So this is a simple redox titration between the solution of iodine and sodium hyposolution, that is Na2H2O3. Okay, so this is very much clear to you. Now, the next one is iodometry. So there is a difference between iodimetry and iodometry. So remember this difference. What is this term iodometry, beta? What do you mean by this term iodometry? So this is an indirect way of doing iodometry, right? So this is an indirect way of doing iodimetry. Here, an oxidizing agent A is made to react with excess of solid Ki. The oxidizing agent oxidize this. We know that oxidizing agent can increase the oxidation state, right? So oxidizing agent oxidize I negative to I2. This iodine is then made to react with the Na2H2O3 solution, right? As can be seen, the gram equivalent weight of Na2H2O3 would be equal to I2, which in turn will equal to that of reacted Ki. This all would be equal to the number of gram equivalent of the compound A. So for better understanding, let's do one numerical related to this topic only so that you can able to solve such questions, right? So what the question asked beta in this? Basically, 5.7 gram of bleaching powder was suspended in 500 ml of water. Now, 25 ml of this solution on treatment with Ki in the presence of HCl liberated iodine, which reacted with 25 4.35 ml of N by 10 Na2H2O3. Calculate the percentage of available chlorine in the bleaching powder. So you have to calculate the percentage of available chlorine in the bleaching powder. So how will you calculate? Let's see. Okay, so let's see how will you calculate this. So first of all, that is a milli equivalent of Na2SO3 is what? So milli equivalent of Na2H2O3 is equal to, volume is already given, 24.35, and what is the normality here? 1 by 10. So this is equal to 1 by 10. So it's equal to nothing but 2.435, right? So this is 2.435. So this is the milli equivalent of Na2SO4. I hope this is clear to you. This would be the milli equivalent of I2 and therefore that of Cl2, which liberate I2 from Ki. Now on the similar basis, milli equivalent of Cl2 in 500 ml, right? So the milli equivalent of Cl2 in 500 ml is nothing but equal to 2.435 multiply by what? That is multiply by, we are talking about the Cl2 in 500 ml, right? So multiply by 20, right? So it's multiply by 20 because it's already given here. So milli equivalent of Cl2 in 500 ml is equal to 2.435 multiplied by 20. So what the value comes out to be, beta? It comes out to be 48.7, right? So it comes out to be 48.7. Now molar equivalent of Cl2, molar equivalent of Cl2 is equal to, or we say milli equivalent of bleaching powder. So milli equivalent of Cl2 is equal to milli equivalent of bleaching powder, right? And which is in terms also equal to milli equivalent of available chlorine, available Cl2. Bleaching powder, right? So the percentage of chlorine comes out to be beta. So what is the percentage of chlorine? So percentage of chlorine is equal to 48.7 divided by 1000 into 35.5 divided by 5.7 into 100. So on solving, you get 30.33%. So in this question, basically they ask the percentage of chlorine. So you can calculate the percentage of chlorine by this. So what is the correct answer, beta? The option A. So option A is the correct answer for this question. I hope this is clear to you. No doubt. Okay. Right. So this is how we can actually solve the such type of question, right? So this is the way to solve this question, and the correct answer for this question is 30. Now, now we are going to do some PYQ questions basically, which is basically related to the this chapter only, a whole chapter that is combining mole concept and equivalent concept. So we are going to solve such question. So let's see the each question in a detail so that you are able to understand this concept as well, right? So try to understand this thing because these questions are very important. These all questions now now we are I'm going to discuss the question, and these all question are related to only previous year questions, and it is the advanced questions only, right? So try to understand this question. So that was the first question asked, beta. Galena, an ore, is partially oxidized by passing air through it at a high temperature. Now, after some time, the passage of air is stopped. So after some time, the passage of air is stopped, but the heating is continued in a closed furnace such that the content undergoes self-reduction. So the weight in kilogram of PB produced per kilogram of O2 consumed is. So you have to calculate the weight in kg of PB produced per kilogram of O2 consumed is. So you have to calculate the weight of this. So for this, again, we need to write the reaction, right? So what the reaction? What do you mean by the galena or beta? What is called galena, right? So galena is nothing but lead sulfide. So galena ore is partially oxide. It means when PBS, lead sulfide, is partially oxidized, we can take here 2 PBS, right? So 2 PBS plus 3 O2, this will produce 2 PBO plus 2 SO2. Now again, the next step, after some time, the passage of it is stopped, but the heating is continued. But the heating is continued in a closed furnace such that content undergoes self-reduction. So the self-reduction, that is 2 PBO react with PBS to form 3 PB plus SO2, right? So what is the combined equation, beta? You can write here. So what is the total reaction for this? This 2 PBO and 2 PBO get cancelled, and this yeah, so you can add 2 PBS plus 1 PBS, that is 3 PBS plus 3 O2, and this will give what? 3 PB plus 3 SO2, right? 3 SO2. So from this question we can observe 3 mole of O2 give 3 mole of PB. So 3 mole of O2 give 3 mole of PB, right? So 3 mole of O2 gave 3 mole of PB, right? Now in this question, read the question very carefully. Thus, in other words, we can say 3 mole means what? O2, we know that 32 gram, 32 into 3, that is 96 kilo. So we can say that 96, right? 96 gram. Okay. So 96 kilogram of O2 gave 621 gram of PB. Okay, because the molecular mass of Pb is already given here, right? So this is already given, sulfur for 32, atomic mass is in gram per mole. So in other words, we can say that 96 gram of O2 will give 3 into 207. So 207 into 3, 37, 621. So this is equal to 621 gram of Pb, right? So 621 gram of PB. So you have to calculate for the 1 kg of O2 give. So 1 gram of O2 give how much? Divided by 96. So in this question, 1 kilogram, right? So 1 kilogram means what, beta? 1000 gram. So 1000 gram will give how much? Right? So just solve this. 621 divided by 96 into 1000. Right? So it comes out to be in basically in this question they want in kilogram. So in kilogram it comes out to be 6.47 kilogram. Right. So this is the question. So total amount of this want is required is 6.47 kilograms. So total 6.47 kilogram of O2, sorry, PB is required when the 1000 gram, or we say 1 kilogram of lead is required. So I hope this is clear to you. Any doubt beta related to this question you can ask? Any doubt? No? Good. So let's see the next question. What the next question asks basically? So the next question is, if the value of the Avogadro number is 6.023 into 10 raised to the 23, we already know, and the value of the Boltzmann constant is this, then the number of significant digit in the calculated value of the universal gas constant is, right? So you have to find the universal gas constant, and in this we have, and on universal gas constant, you have to identify the significance figure. So this is also the advanced problem, right? So how will you solve this? We know that what is universal gas constant R, which is equal to K into Na. That is Boltzmann constant into Avogadro number. So this is K into Na. Now what is K here? So K is already given 1.380 into 10 ki power minus 23. What is Na here? 6.023, 10 raised to the power 23. So on solving, what we get, beta? We get this is 10 ki power 23, 10 ki power 23. They are cancel out each other, and 1.380 multiplied by 6.023. So on solving, we get this like yeah, 8.31174, or approximately we can write 8.312. We can write this 8.312. Since K and Na both have a 4 significance figure, right? Because we know that in this also we have a 4 significance figure, and in this also we have a 4 significance figure. So both K and Na having 4 significance figures, so the value of R is also round off to the 4 significance figure. That's why we also round off this to the 4 significance figure. So the number of significant figure is nothing but 4. So this is quite simple. But students face problem in this. They don't know the relationship between the universal gas constant and the Avogadro number and the Boltzmann constant, right? So this is the relationship between these three, universal gas constant R and Avogadro number into Boltzmann constant, right? So the total significant digit in the calculation is 4. So it is equal to 4 only, right? Okay. Now, in this question is also very, very simple question, and this question is very easy. So you have to identify the which has the maximum number of atoms, right? So how will you identify beta which one has the maximum number of atoms? So for this, we know that mole concept. We have to use the mole concept. That is number of atoms. We know that number of atoms is equal to number of moles. Number of atom is equal to number of moles multiply, or we say divided by, not multiply, divided by Avogadro number, that is Na. So this is how you can find the number of atoms, right? So number of atom is equal to number of moles divided by, wait for a second, number of moles divided by, no, it's multiply by Na. So sorry for this. Let me erase this. So can you, yeah. Okay, so this is how you can find basically beta number of atom is nothing but number of moles into my Avogadro number. Okay, so let's see for the first one. If I'm talking about the carbon, right? So we know that number of atom for the carbon is number of atoms in 24 gram. Okay, so we know that what is mole? Mole mass upon molecular mass. So mole is 24 divided by 12 into Avogadro number, that is Na. So it comes out to be 2Na. So it is equal to 2Na. Now let's see for the next one, that is 56 gram of Fe. So 56 gram of Fe, so number of atoms in 56 gram. So mass is 56, molar mass is also 56 into Na. So it comes out to be only Na. So it is equal to Na only. Now for the third one, that is 27 gram of aluminum. So number of atom is also equal to, we know that molecular mass of Al is also 27 into Na. So it also comes out to be Na. Now in the fourth one, silver. So we know that molecular mass of silver is also given 108 into Na. So this is also equal to Na. Right? So which one having maximum number of atom beta? So the first one, that is 24 gram of C12. I hope this is clear to you. This is very simple question, and this question asked in your advanced paper, right? So this is very simple to solve, which has the maximum number of atoms. So you can calculate this, right? Just using the mole concept, because we know that the number of moles and number of atoms and relation between the number of atoms and the number of moles, right? So just using this relation only, we can able to calculate this, right? So this is the maximum number of atoms we have. Now, in this question, they ask you to calculate how many moles of electron weight 1 kilogram. So you have to identify how many moles of electron weight 1 kilogram. Yes, can anyone? Chalo. I'll solve, no issue. Just tell me, what is the mass of an electron beta? You have to calculate how many moles of electron weight 1 kilogram. Now, it means how much mole we required for making 1 kilogram. So we all know that mass of electron is what? Mass of electron. So mass of electron is nothing but it is equal to 9.1 into 10 ki power minus 31 kilogram, right? So this is the mass of electron, which is equal to 9.1 into 10 ki power minus 31 kilogram. Now, mass of 1 mole of electron, right? So mass of 1 mole of electron is nothing but 9.1 10 ki power minus 31 into Avogadro number, that is 6.023 and 10 ki power 23. Clear? So this is the mass of an electron, which is equal to 9.1 into 10 ki power minus 33 into Avogadro number is equal to this, right? So on solving, what you get beta? 9 6 the 54, right? And 10 raised to the power is already cancel out each other. So on solving, you'll get this. Okay. Now you have to calculate the number of moles, right? So the number of moles, the number of mole, the number of mole of electron, the number of mole of electron that weight 1 kilogram. 1 kilogram, right? So mass of electron is nothing but is equal to 9.1 into 10 ki power 30, and this one is 9.1 into 10 ki power minus 31 kilogram. Mass of 1 mole of electron is 9.1 into this. The number of mole of electron that weight 1 kilogram. is equal to nothing but 1 divided by 9.1 into 6.023 into 10 ki power minus 8, right? Because 10 ki power minus 31 and 23 cancel out each other to form 10 ki power minus 8. So on solving, what you get? You get this is equal to nothing but this one, that is option D. So no need to solve this as well because we get directly the answer. Because we know that the mass of one electron is this much graph. So mass of 1 mole of electron is this one. So thus the number of electron that present in 1 kilogram is equal to this. That is 1 upon 9.1 into 6.023 into 10 to the power minus 3. So this is how we can actually calculate. I hope this is clear to you all. Now, the next one is a mixture of X is equal to 0.2 mole of CONH3 is given, right? So in this, a mixture of 0.02 mole of CONH3 5SO4 is and 0.02 mole of CONH3BSO4 was prepared in 2 liters of solution. 1 liter of the mixture if X in excess AgNO3 give Y. 1 liter of mixture X plus excess of BaCl2 give Z. The number of moles of Z, Y and Z. So you have to calculate the number of moles of Y and Z. So let's see the reaction first. We know that when the CO, that is CO NH3, right? CONH3 5 SO4 and Br, when they react with AgNO3, right, in excess. So what will form? It will form only one AgBr because we know that this is only a ionizable ion. This is unionizable ion. So this coordination pair does not break. This is only, so there is only one ion present in form of Br. So here the form is AgBr only. So the formation is like CO NH3 5 SO4 NO3 plus AgBr, right? So the AgBr is formed. So we know that when the mixture of X is equal to 0.2 mole of this. So mixture X, it means 0.02 mole of this will produce how much? So 0.02 mole of this produce when this react with this. So they produce 0.01 mole, right? It means in 1 liter, there will be 0.01 mole of each Br and 0.01 mole of that is sulfate SO4 is present, right? So 0.01 present, right? So this is equal to 0.01 mole. Okay, so this comes out to be 0.01 mole per liter and this is equal to Y. Now on the similar basis, what happened when this will react? So when this react like CO NH3, right? So when CO NH3, this is 5 times, and Br SO4 react with BaCl2, right? When this react with BaCl2 in excess, what will they produce? It produce CO NH3 5 Br Cl2, right? So when the CONH3 5 Br SO4 plus BaCl2 react to produce CONH3 5 Br and Cl2 plus BaSO4. So 0.01 more. And this is equal to Z. So what is Y and Z here, beta? So Y and Z comes out to be Y and Z, that is 0.1 and 0.1. So which option is correct? That is option number A. So option number A is absolutely correct for this question. So I hope this is clear to you. Right? Okay. So let's see this question and try to solve this question. I'll giving you 2 minutes till I take some water. So try to solve this question. What the question asks, and how will you calculate this, right? So this is basically from the titration part that we studied today. So try to solve this question. I'll give you 2 minutes. I just take water and come till try to solve this question. Yes. So what the question asks, in aqueous solution of 6.3 gram of oxalic acid dihydrate is made up to 250 ml. The volume of the 0.1 normality NaOH required to completely neutralize 10 ml of this solution is. Okay. So here you have to, the correct answer is what, Peter? The correct answer is for this question either 40, 20, 10 or 4. Let's see the solution. We know that N factor for H2 C2O4 dot 2H2O is equal to 2, right? So this is the oxalic acid dehydrated, this one. So what is the N factor here? So N factor is 2. That is oxalic acid dehydrated. Now, normality is equal to weight into 2 into 1000 divided by molecular weight, right? Molecular weight divided by molecular weight into what? We know that on normality is what? That is weight into 2 into 1000 divided molecular weight into 250. Okay, into 250. So this is the formula of normality. This is very much similar to the molarity, just in terms of mass, medium, gram equivalent weight. So gram equivalent weight is nothing but molecular weight gram equivalent weight is nothing but weight upon me and factor. So it is equal to weight upon 2. Right. Now we can solve this because we know the values of each and everything. So just put the value. Weight here is nothing but 6.3, right? And this will become 2 into 1000 become 2000. Molecular weight. So molecular weight is 126. 126 for this. This having molecular weight 126. So the molecular weight is 126 and this is 250. So on solving, this will from 250 for the 8 times, right? So on solving, you get this 0.4, right? So on solving, you get N is 0.4. Now equating number of equivalents. So I'll write here equating number of equivalent. Okay, so equating number of equivalent, that is N1 V1 is equal to N2 and this is V2. So what is N1 here? That is 0.4. What is V1? That is 10. Again, this is V2 into 0.1. Right. So what the volume comes out to be? Volume, that is V2 is equal to 40 ml. Right? Volume comes out to be 40 ml. So which one is the correct option for this question? That is option A. So option A is absolutely correct for this question, right? So I hope this is clear to you. Okay. Now, you have to calculate the normality of 3 molar. Okay, so you have to calculate the normality of 3 molar phosphorus acid. So we know that this question is very, very easy. We know that what is the relationship between normality and molarity, beta? So we know normality is nothing but is equal to n factor into molarity. Okay, so normality is nothing but it is equal to n factor into molarity. Okay, so this is equal to n factor into molarity. So how will you calculate this n factor? How will you calculate this n factor, beta? We know that in case of S3PO4, S3PO4, we already discussed this thing in yesterday class, how to draw the structure of such thing. For S3PO4, we know the P double bond O, this having OH, OH, and this is H. So what is the basicity of this? That is 2. So basicity is equal to 2. So here basicity is equal to 2, or we say there is a 2 replaceable OH hydrogen is there, right? So 2 replaceable hydrogen is present here. So basicity is 2, it means 2 n factor. So it is equal to 2 into molarity is already given 0.3. This comes out to be 0.6. So which option is correct, beta? That is option number D. So option number D is absolutely correct. This is very, very simple question. Just you have to calculate the n factor. If you know the n factor, then just multiply by molarity. And when you do molarity with the n factor, you'll get the answer. Okay, so I hope this is very simple question. Now, this question is also very important. In this question, they are asking a certain compound contain magnesium, carbon, right? So you have to find out the ratio of this, right? So the certain compound consists of 3 things, that is magnesium, carbon, and nitrogen in the mass ratio 12, 12, and 14. The formula of the compound, if you have to calculate the formula. So the question is already given, magnesium, carbon, and nitrogen, and it is equal to, we know that what is the mole of this? So mass upon molar mass, that is 24. For carbon, it is 12 upon 12. For nitrogen, it is 14 upon 14. So it comes out to be Bharat 12 to the, so 1 by 2 ratio 1 ratio 1, or we say it comes out to be 1 ratio 2 ratio 2, right? Is it clear to you? 1 ratio 2 ratio 2. So what is the formula? So the formula is Mg. Mg is 1. Carbon is what, beta? Carbon is 2 and N is also 2. So which one is the correct? Mg2, C2 and N2. Yeah, this one. Option D. This Mg, C2 and N2. So this is the correct. So I hope this is clear to you. This is very simple question. Just a certain compound having mass percentage is given. Just you calculate the mole, and by knowing the mole, you can easily calculate this value as well. Okay. So I hope this is clear to you. Right? Good. Now, let's see the this question. This question: 50 gram of sample of sodium hydroxide required for the complete neutralization, right? For the complete neutralization. So 1 liter of 1 normality HCl. What is the percentage purity of NaOH? So how will you calculate, beta? We know that weight is equal to nothing but normality into gram equivalent weight. So into volume. So this is how we can calculate this. Now the percentage purity of this is also given. So 50 gram of this is given. What is the percentage purity of NaOH? So you have to calculate the percentage purity of NaOH only. How will you calculate, beta? Can anyone tell me? How will you calculate this? If weight is equal to normality into gram equivalent weight into volume, then you can calculate volume now. How will you calculate volume? Yes. So you have to calculate the percentage purity of NaOH. So we know that percentage purity of NaOH, right? So percentage purity of NaOH, we know that NaOH having mass 50 upon my total mass, that is 50 into 100. So it comes out to be 80%, right? So I hope this is clear to you how 80% comes. How did it come? 50 gram of sample of sodium hydroxide is treated with this. Okay, so this is how you can able to solve the percentage purity of NaOH. So by using this calculate W, just put the value and calculate percentage purity of NaOH. Now, this question is also very, very important, and this is a JEE Advanced 2022 paper 2 question. So what the question asks, beta? Try to read the question as well. What the question asks, what you have to calculate in this question. So in this question, the question is asking about to check the principle of multiple proportion, a series of pure binary compound PMQM are analyzed in their composition and tabulated below. The correct options are compound 1, 50% weight of percentage of P is 50, 50, 44, 55, 40, and 60. Now you have to identify out of option A, B, C, D, which one is correct and which one is not correct, right? So let's see the solution of this. We know that it is already given that it is equal to 44 and 55.6, 40 and 60, right? So how will you solve this? We know that if I'm talking about, you know that if the empirical formula, let us do this question by option elimination method, right? So I'm going to discuss this option and you find which option is correct. So if empirical formula, so if empirical formula of compound 3 is given P3 Q2. Okay. What does it mean? It means that is 40 upon MP, that is 60 upon MQ. This is equal to 3 by 2, right? Okay. So this is 40 upon MP into MQ into 60 is equal to 3 by 2. So we can calculate here MQ upon MP is equal to 9 by 4, 9 by 4. And in this question, already given that MP is equal to 20. So put this value, what is the MQ comes out to be? MQ is equal to 45. So you can observe here, MQ is 45, MP is 20. So empirical formula is what? So the option B, try to observe the option B that is P3 Q2 atomic weight of P is 20 and the Q is 45. So this is absolutely correct. It comes out to be this one. So this is correct. Again, let's see for the option C. If the empirical formula for C, I'm talking about C, right? So for this empirical formula of the compound is compound 2 is PQ. So empirical formula is given here. It is equal to PQ. What is the molar ratio for this? So the molar ratio become 44.4 divided by 1, and this is 55.6 divided by 1. This value is already given in the table, right? So on solving, you'll get this comes out to be around 0.8. So the empirical formula of the compound is nothing but empirical formula of the compound 1 is nothing but P5Q4, right? P5Q4. So the molar ratio become 50 divided by 5, 4 divided by 50, which is equal to 4 by 5, or we say it comes out to be 0.8. Since the molar compound is less, compound of equal or less than this C, hence the option C is absolutely correct. So from these two question, which option is correct, beta? So the two options, that is option number P and Q, these two options are absolutely correct. I hope this is clear to you. Right? So this is how you can actually solve such type of questions, right? So this is the way we solve. So today class, we are solving in entire 2 days. We are solving mole concept and equivalent concept in detail. And you solve many questions and I cover almost all topic, which is very, very important for the advanced point of view. From the next class, that is from tomorrow, we are going to discuss structure of atom, right? So from the tomorrow class, we are going to discuss structure of atom. So be prepared well for this and try to try to solve this question as much as you can so that you can able to solve such questions. Okay, so this is all for today class. Let's meet in the next class where we'll solve many questions related to this.